All right. Well, thank you for joining me for video number two, problems. I think three, probably three, four, and five. Um, Please understand that I would love you guys to watch these and benefit from these videos, but I would really ask that you try the problems on your phone on your own before you just jump right to the video and write down, copy things down. Um, I have mixed emotions about doing this because I don't want people to rely too heavily. I'd like you to try on your own and then double check and get clarification. So pause problems before you try something on your own. If you got something that you learned, then pause it and then try the next problem on your own before you just watch the next video. So anyway, with that stated, let's go ahead and see what happens when we get to number three. Now, our first problems specifically asked us to utilize this idea of factored form. Our first videos, sorry that my computer's being slow. Our first videos asked us to put it in factored form where we have our little diamond and all that kind of stuff. These problems down here ask us to go a different direction and use axis of symmetry and patterns. So that's what we're going to try to do. That's going to be a slightly different version. So remember, the first thing we want to do is identify what A is, what B is, and what C is, and use our little formula, which is opposite B over 2A, and that is always that formula. And so the opposite of positive 4 is negative 4. And if I double negative 2, I get negative 4, which means my line of symmetry happened at x equals 1. Okay, so I always get that number and I immediately throw it on my graph. I make a nice simple dotted graph at x equals 1, and then I'm going to center my table right here at x equals 1, which means I'm going to go up from 1. I'm going to go down from 1. Okay, so here we go. Now, next phase, we are going to go to the original problem, and everywhere there was an x, I'm going to replace it with a parenthesis. And then in the place of that x, I'm going to use that x is positive 1. Now, a big deal for me is to make sure you guys see little pieces of evidence that we are doing well. 1 squared is still 1. Right? Order of operation says do your exponents first, right? Exponents are first after, but there's nothing to do in the parentheses. It's just a number 1. So 1 squared is 1, and 1 times negative 2 is negative 2. 4 times 1 is 4, and of course this 7 that is sitting there is literally just a 7, so I can't do anything more with that. And remember, we talked in class about the fact that if these two numbers were done correctly, the second number is twice as big as the first and the opposite sign, which tells you we did okay. Now, putting it all together, I took a negative 2 and a positive 4, which gives me positive 2 plus 7 more makes 9. Okay. That is going to be my vertex. So here is my vertex. This is at 1, 9. This problem is a little trickier because my 1, 3, 5, 7 pattern got multiplied by A, which is negative 2. That's a really important part that you have to watch for, is if there is a number there for A, we have to honor that, which means I need to go down 2, and then I need to go down 6, and then I need to go down 10 from, again, from that vertex. So go down 2, go down, it says 2, 7, 3, 1, 1, 2, 3, 1, here it is. And then at 4, I got negative 9, which is way down here. 1, 2, 3, 1, 2, 3. Keep in mind, you can use your line of symmetry since this point is exactly 1, 2, 3 to the right. I could go 3 to the left, and then I just do a really nice, smooth curve, trying my best to hit those points nice and pretty. Now, one of the things that we did talk about in class is it's always a good idea to go into Desmos specifically when we're practicing a problem and making sure that we have done it right. So again, I'm going to go ahead and get rid of this problem, and I'm going to put in my new table. So when I plugged in -2, I got -9. When I plugged in -1, I got 1. And when I plugged in 0, I got 7. When I plugged in 1, I got 9. When I plugged in 2, I got 7. When I plugged in 3, I got 1. And when I plugged in 4, I got -9. Now, hopefully I see evidence that this graph looks correct to me. And then I could just see what happens if I typed in my original equation, which is y equals -2x to the second. And remember, you can hit Shift 6. I need to hit arrow over to get out of that exponent. Plus 4x, and then a plus 7. And if I have done this right, it should hit my data values real nice and pretty. And you'll see that it did. Sometimes I like to actually open this up and change the font on those dots to much larger numbers. That way you can really see that it hit those numbers perfect that we did. So that tells me I did okay. All right. So hopefully that's good. So let's go ahead and get back to what we're doing. Again, this is a strategy best used when the problem doesn't factor. I didn't show that, but let's do that over here. So let's say I wanted to factor. Well, 3 times 7 is 21, right? This middle number is 12, and I go through all of the numbers that multiply to 21, which is 1 and 21 or 3 and 7, but none of those numbers can combine in any way to give me the number that I'm looking for, which is -12. That means it is not factorable. This thing right here is actually called a prime, meaning it can't be broken down. So we're going to do our opposite b over 2a, which is going to be positive 12 over 2 times 3, which is 6, and that gave me 2. And now what I need to do is go in there and plug in the number 2 into my original problem, which, if I plug in 2 into the original problem, let's see how we're doing here. If I plug in 2 here and here, oh, I guess I already did it there. 2 squared is 4, and 4, because exponents come before multiplying, so 4 times 3 is 12. 12 times 2 is 24, but that's a -12, so there you go. And notice again, this is twice as big. And so if we put that all together, 12 minus 24 is -12. -12 plus 7 is -5. So we have that here. We're going to start at x equals 2. -5, and keep in mind my 1, 3, 5, 7 pattern is going to get, in this case, multiplied by the number 3. So I need to move over 1 up 3, move over 1 up 9, move over 1 up 15, and over 1 up 21. Now, I would like you guys to do that on your own before you watch me do it. And I'm just going to show you a quick answer of that. So here we go. I'm just going to show you the answer to try to make this a little bit of a faster video than what we have so far. But hopefully this is going to show up the way that I want it to. Here we go. This is a nice little table for number 4 right here. Notice we went up 3 and then up 9 and then up 22, and we graph those values. And so you can hit pause if you want to, because I'm going to exit off of that right now. Okay, so there was an answer key, so you could see it. Let's just keep it going. Now, number 5 is the last one that I wanted to do for this particular video. So here we go. So number 5, very similar to number 2 that we already did earlier on a previous video. Can we use the evidence that's in front of us to come up with the equation of that graph? Now, let's see what we've got. So the first thing that I notice is this graph hits right here beautifully at -5 and at +1. Okay, so notice that it does say standard form. So I want something that looks like ax squared plus bx plus c. But I'm going to do something a little bit tricky. I'm going to move this up so you can see that. But since it hits here at 5, and that is a root, then x minus 5 is a factor. And since it hits here at positive 1, that means x minus, or careful about that. It hits at negative 5, so x plus 5 is a factor. And since it hits at positive 1, then x minus 1 is going to be that factor. So I already know a lot about what this problem is, but I can also look for one more thing, is that if I look over and I go over 1, it went down 1, 2. It went over 1 and down 2. And then when it went over 1 and went down, let's see, 1, 2, 3, 4, 5, 6. Oh, so my 1, 3, 5 pattern, now it went down 10. So if it went down 2 and then down 6 and then down 10, my 1, 3, 5 pattern got all multiplied by negative 2, which means I need a negative 2 right there. Now that is the right answer, but it's not in the right form because it specifically says in standard form. So let's just finish that out. So depending on the method that you like to do, what I would like to see you do is just do x plus 5 and x minus 1. That's going to be, if you multiply, we got x squared. That's 5x. This goes back to our very first day on quadratics. And negative 1 times 5 is negative 5. So I've got x squared. I've got a total of 4x's here and minus 5, but that is still being multiplied by negative 2. And so my final answer for standard form would be negative 2x squared, negative 8x, and positive 10. And the cool thing is if you wanted to, what we could do is we could go back one more time to Desmos. See if I can find my Desmos screen. I'm not finding my Desmos screen, so maybe I'm not going to do that. But let's go ahead and stop share. I was going to go back, but again, I could go into Desmos one last time. I guess I don't have it, and I got a class going to start here in a moment. But if I went to Desmos and opened it up, I just saw it finally. I could type in this data right here, this data right here, and they should be overlapping each other absolutely perfectly. They should be right on top of each other because they're the same equation in different forms, and it should look identical to the graph that we have sitting right here. All right. Hey, I hope that was helpful. I will see you guys later back in class. Bye-bye.